Hey guys, today we're going to take what we've learned about using square roots and how to solve a square root or simplify a square root, and we're going to apply that to quadratic equations. Now remember, quadratic equations are quadratic because of the variable squared, and so we've been looking at a lot of squared variables lately. So we also learned in the very first lesson in this unit that there in a quadratic equation you can have one solution, two solutions, or no solutions. So we'll kind of see how that plays out in some of the situations that we're gonna, or some of the equations that we're gonna look at today. So first off, I want you to look right where it says 2 key points to remember. It says even though we don't technically use this all the time, the square root of 36 is both a positive 6 and a negative 6. We alluded to that a little bit earlier. I wasn't very consistent in writing it every time, but just so you know that that is a truth, and that is going to play into our answers today. Let's see. For number 2, to undo a square, you take the square root. So the opposite also applies. And what you do to one side of the equal sign, you must also do to the other side of the equal sign. So let's look at what we got here. We have the first one is x squared equals 16. So now, okay, let me bring you on back. Now, I do know that last year you did Pythagorean theorem. Pythagorean theorem was a squared plus b squared equals c squared. And almost always the very last step in those equations would be something like b squared equals 100 or c squared equals 25. And then you had to find the square root of both sides because you were trying to get the a by itself, the b by itself, or the c by itself. We're going to do that again. That is exactly what we're going to do. We're going to get rid of that square, and to do that is to find the square root of it. So for example 1a, it's kind of like putting a radical on top of both sides. So we know that x is going to equal not only 4, but a positive or a negative 4. Let's look at the next one. To get rid of that radical, I have to put a square root over both. Now, here's something to know. You cannot have a negative under a radical sign. So right away, there are no real solutions. All right. So remember, we talked about that before, that we can have one solution, no solution, or we can have two solutions. So in the first one, we had two solutions. The second, we had no real solutions. Let's look at the next problem here. I'm going to go ahead and solve it like I would solve any other equation. I'm going to divide both sides by -2. I get x squared equals a positive 25. Again, now I'm going to go ahead, I don't know, I'm lazy. I like to just put one huge big radical over the whole thing. So I get x equals the square root of 25 is either a positive or a negative 25. Moving on here. All right, again, I'm going to solve this like I would solve any other equation. We're going to get to that last step. It's going to just be a little bit different. So I'm going to subtract 4 from both sides. X squared equals 36. To get rid of the 2, the little exponent 2, I must find the square root of it. So x equals a positive or a negative 6. Two solutions. Let's go to the next one. -5 minus 5. X squared equals the square root of 48. Okay, we're going to go back to what we talked about earlier in the other lesson about doing prime factorization. I'm going to take that 48 and I'm going to start breaking it down. 2 times 6, 2 times 3. Here's a pair to pull out. Here's a pair to pull out. And I am left with that 3. So I'm going to, again, to find the square root of both of these, x equals, and we're going to step back a little bit. We're going to pull 1, 2 out. We're going to pull another 2 out. And then the 3 is left inside. So x equals 4 to the square root of 3. And there's a plus minus in front of that 4. All right. I hope you're seeing patterns again. It's always patterns. All right, the next one. I'm going to, again, this is a quadratic equation. I'm going to move the 25 over to solve it. I'm going to move the 25 over to the other side. 4x squared equals 25. Then I'm going to divide both sides by 4. And I get that x squared by itself. And then on the other side, I have a 25 over 4. Okay, now I'm going to find the square root of both sides. Because I'm lazy, I'm going to make one old big square root over that. So I know that this is now x equals, on this other side, it's the square root of 25 and the square root of 4. So we know that that would be a plus minus 5 over 2. All right, moving on. Hope you're catching on. All right, I'm going to go ahead and I'm going to solve like I solve any other equation. 3x squared is 147. Divide both sides by 3. X squared equals 49. And again, I'm just going to go put a big old radical sign over the whole thing. X equals plus minus 7. All right, next one. Now this one looks a little bit differently, but again, I just want to go ahead and get rid of the square. So I'm going to go ahead and do a square root over the entire thing. And I'm left with x plus 5 equals 8. X plus 5 equals 9. All right, now this is a, let me go ahead and erase that 9 one more time. This is a positive negative 9. So watch how that affects my answer. I can either do, and normally I would subtract 5 from both sides, and I'm going to do that. But I'm going to break this now into two different equations. X plus 5 equals 9, and x plus 5 equals a negative 9. So minus 5 minus 5 minus 5 minus 5. X is 4 and x is negative 14. And here we have our two answers, our two solutions to this problem. Let's do that. Well, I don't think I need to do it again. Let's save some time on that one. Let's move on down. Okay, this one's a little bit weirder. So I'm going to go ahead and I'm going to do my big old radical sign over the whole thing. And I get x minus 4 equals the square root of 75. All right, square root of 75 can be broken down. I mean, when I see 75, I see a perfect square right away. 25, perfect square. I can break that down if you need to see the pair. There's the pair. So this is x minus 4 equals a plus minus 5, and the 3 is stuck inside. Okay, now watch this next step. So to solve this equation, I need to add 4 to both sides. Plus 4 plus 4. The problem is I can't add 4 to the 5, and I can't add 4 to the square root of 3. They're not like terms. So look and see what my answers end up being. I have x equals, and the best way to write this is to go ahead and put the 4 in the front. So I'm going to put the 4 in the front. Well, okay, I'm going to go ahead and put the 4 in the front, and that's going to be a plus 5 to the square root of 3, or I shouldn't say or, and I get x equals 4 minus 5 to the square root of 3. So I have two answers here, or two solutions. Okay, I'm going to leave it at that for time. I don't ever like to go over 15 minutes. And if you use these notes, I hope you wrote everything down, because they're a great resource to go back to when you get to those really weird problems. See you later. Bye-bye.